Hello students, and welcome to our lesson on equations and their solutions. In this lesson, the main thing we're going to be talking about is the difference between expressions, equations, and functions. We're going to talk about the different number of solutions that you can get to an equation, and then we're going to go over basic problem solving steps and how to verify that your answer is in fact correct. In later topic, we're going to solve equations that require more steps. In this topic, we're just going to be doing one-step equations. So everything is going to be nice and simple, at least hopefully it'll feel that way. And this is mostly designed to be review for what we're going to be doing in future topics. All right, so we have expressions, equations, and functions. In mathematics, we often group numbers and or variables together to create these three things. So we're trying to create either expressions, which are the simplest thing we have, or we take two expressions and put an equal sign between them to create equations, or those equations might have special meanings and they might represent relationships between two or more variables, in which case we call them functions. So now for each one of those, we're going to just talk about how you can tell them apart. Expressions do not contain any equal signs. So an expression could be any combination of variables and numbers. So it might be something like 2 times x plus 3, but notice that there's no equal sign there. Okay, an expression is just one side of what we would normally do for an equation. So for an equation, we will include an equal sign, but for an expression, we just have a combination of numbers and variables, no equal sign. Equations there on the other side do contain equal signs. So an equation might look like instead of 2x plus 3, we might take 2x plus 3 and set it equal to something, like maybe equal to 6x. And by setting the expression equal to another expression, then we get what is known as an equation. And we would then be able to solve this equation for the value of x that makes the equation true. Functions, on the other hand, functions are like equations. They are types of equations, but they demonstrate a relationship between two or more. So I'm going to write 2 plus variables. Okay. I say 2 plus because even though for our purposes right now, we're only going to have two variables, technically functions can take in any number of variables. Because if you think about real life, usually there's more than one variable in whatever situation we're describing, right? So in various situations, we might take multiple inputs in, such as if we're trying to calculate how much energy is used to move an object, we might take into account not only the pushing that we're doing, but also the friction that's taking place and find some sort of relationship between those that gives us the force being used. But generally speaking, in this class, when we have equations, most of them, or sorry, when we have functions, most of them will just have two variables. The exception to that is when we talk about finance. In financial terms, we might have a lot of variables. We might have interest rates, we might have mortgages, or sorry, principal values, and we might have time. So time, rates, and principal will all be variables in the same function that we're going to be looking at. So functions are relationships between two or more variables. And then the numbers and or variables that are separated by plus or minus signs are called the terms of the expression. So whenever we have expressions in equations or functions, we can separate different terms using addition and subtraction signs. All right, and when we talk about these things, usually we use the same few words each time. For expressions, generally we simplify expressions. Equations are generally solved, and functions are most often graphed or evaluated. Okay, so those two are going to go together. So functions, usually we either graph or evaluate them, where evaluate means to plug in values for the variables. Equations, usually we are solving for a variable. And expressions, generally we simplify expressions to make them look as nice as possible. All right, so now we focus on equations for the rest of this. An equation is a mathematical sentence stating that one expression is equal to another expression. A solution to an equation is any replacement of a variable that makes a true statement. So what we're going to be doing when we solve equations is trying to find the value of a variable that creates a true statement when we plug that variable into the equation. And by true statement, I mean something like 3 equals 3 or 0 equals 0, something that is fundamentally true. All right, so now before we learn how to solve equations, first we need to learn how to test if our answer is right. That way at the end of every problem, we can go backwards and see if we actually did it right. So for example, number 1 here, is -1 the solution to 7x minus 2 equals 4x plus 5? So first things first, when we say is -1 the solution, what we really mean by -1 right here is x equals -1. Okay, so when we just say -1, from context, we're supposed to understand that that refers to the x value. So now the way we check if it's actually right is we evaluate this equation with -1 plugged in for every x. So to do that, we're going to take 7x minus 2 and write it as 7 times -1 minus 2. Now on the right side, 4x plus 5 is going to become 4 times -1 plus 5. We can simplify each side. 7 times -1 is -7. Minus 2 gives us -9 on the left. And on the right side, 4 times -1 is -4. -4 plus 5 is +1. So when we look at this statement now, it says that -9 equals 1. Well, that is false. Okay, -9 does not equal 1. And so the fact that that's false tells us that x equals -1 is not the solution. Okay, so a true statement would mean that our answer is a solution, but the fact that we get a false statement says that this was not the solution to begin with. So whenever you get an answer from solving an equation, you should always plug that answer back in and see if you get a true statement. That way you know that you're correct. Okay, let's see what it looks like when we do get a true statement. So for number 2 here, verify that 2, meaning x equals 2, is the solution to 5 plus 2x equals 15 minus 3x. If we plug in 2 for each of these x's, we're going to get 5 plus 2 times 2 equals 15 minus 3 times 2. On the left side, we have 5 plus 4, which is 9. And on the right side, we have 15 minus 6, which is also 9. So the fact that right here, we get a true statement means that x equals 2 is a solution. Okay, so true statement means that the value for x we started with was in fact a solution. All right, so now more about solutions. Because equations don't always just have one nice, easy answer. Sometimes they do, but it's really just not always the case. So let's take a look at our few options here. So on the left, we have x plus 1 equals 5. If we subtract 1 from both sides, we would get that x equals 4. We got one answer, x equals 4. So what we can say then is that there is one distinct solution where distinct, if I spell that right, distinct means that it's unique. There's nothing else the same as it. So one distinct solution. So it's not a repeated solution. There's not 2 4s as the answers. It's just 1 4. X equals 4 is our only answer. So one distinct solution, and we call this a conditional equation. So conditional equation, where it's conditional because it's true under the condition that x equals 4. So I'm going to put that as a little caveat. So we call it conditional because it's true under the condition that x is 4. What that means is that if we plug in anything other than x equals 4, we are not going to get the correct answer here. So it is only true if x equals 4. All right, the next one, x plus 3 equals x plus 3. Notice that if we subtract 3 from both sides, we're going to end up with x equals x. And if we subtract x from both sides, we get 0 equals 0. So both sides are the same. All right, if both sides are the same, that means that x can be any real number. So x can be any real, and the pound sign there means number. So if x can be any real number, that means x could be 4, 5, 6, -2, -3.1. It doesn't actually matter what x is. All right, so x can be anything. That means that there are infinitely many solutions. Because there are infinitely many real numbers, which means there are infinitely many solutions to this equation. It does not matter what x is, the statement will be true no matter what we plug in for x. When this happens, we call this being dependent, or we call it being an identity. Okay, we call it an identity sometimes because we have the same thing on both sides. So if you've ever seen that Spider-Man meme where the Spider-Mans all point at each other and they're like, hey, you're Spider-Man. No, I'm Spider-Man. No, we're both Spider-Man. So it's kind of like that. An identity is where both sides look exactly the same because they are in fact the same thing. All right, so we call that being dependent or an identity. And then these two options, these first two here, both of these together have answers. So we call both of these being consistent. Okay, where consistent just means that solutions exist. All right, so we have two possibilities that fall under the consistent category, which means that we actually have solutions. Now, the last one over there, we have x plus 3 equals x plus 4. If you subtract 3 from both sides, you get x equals x plus 1. Then if you subtract x from both sides, you'd get 0 equals 1. Well, 0 doesn't equal 1. There's no way to answer this. Okay, so there is no value of x that works. So no value of x will work. And what this means is that there is no solution. Okay, so no solution. And we call this one of two things. First of all, before I say that, no solution, we can also write a 0 with a line through it means no solution. Or technically, we can write squiggly braces with nothing inside. However, I strongly prefer that you don't use that one. So if that's what you've been taught in the past, strong preference. Please don't use that one. But the circle with the line through it, that one does work for no solution. Or you can just write no solution. We call this when there is no value of x that works. We call this either being inconsistent or a contradiction. Okay, so inconsistent or contradiction. So notice the first two we labeled as consistent, and now the last one we're labeling as inconsistent. So when we have answers, then we're consistent, essentially meaning, hey, this statement can be solved. But when we don't have answers, we call it being inconsistent or a contradiction. Essentially, we feel like we were lied to. X plus 3 never equals x plus 4, no matter what x is. It just never happens. All right, so now that being said, let's go ahead and try to actually find some solutions. So to solve basic equations, the goal is to get the variable alone or isolated. Okay, alone and isolated mean the same thing. So if your parents or anyone has ever told you, hey, why do you isolate yourself all the time and play video games in your room? Well, you're making yourself alone. So alone, isolated, same thing. And we get the variable alone or isolated by using inverse operations, meaning we do the opposite of whatever's currently happening in the problem. And so what you should do is think of an equation like a scale where the equal sign is the fulcrum. And what we want to do is to keep balance. Okay, so to keep balance, whatever is done on one side must also be done on the other. And if you didn't get that reference of a scale, by the way, if you imagine a triangle with a line going over it, like a seesaw, you've probably seen a seesaw, the fulcrum is that point right there in the middle. Okay, so it's the balance point where we tip the scale to each side. All right, so now solutions can be verified by plugging them back in. And that is what we were doing on the first page where we were verifying solutions. So you're going to notice that I'm going to verify the solution for number 3, but given that I have a master's degree in mathematics, I'm going to trust my work for the rest of problems. It's very important that you understand where you are at in your mathematics journey. And when you're solving something that you personally consider to be trivial, meaning you're like, this is easy, I know how to do this, then you get to take your own liberties and maybe you skip the plugging in step. But when you are ever unsure, you should always go back and check your work. And so I just told you, I get to skip steps here because I'm a master mathematician. But still, with that, if I am ever doing something in mathematics, whether it's teaching or for my own personal business, I will check my work and plug things back in if I don't know that I got the right answer 100%. So please always check your answers, especially on a test, because you got to understand that you are still at the developmental level. You haven't mastered it yet. That being said, for number three, you're going to notice very easy problem. If you are doing something that you consider trivial, it is up to you when you check your work and when you do not. However, please be aware that I highly, highly recommend on anything that you are getting credit for where someone else is going to grade you, you should be checking your work before they check your work. All right, that being said, number three here, x plus 5 equals 12. We said that we want to solve this or get the variable alone using inverse operations. And so by inverse operations, what we mean is that right now it says x plus 5. To get that variable alone, we're going to do the opposite of plus 5, which is minus 5. So I will subtract 5 on both sides. That gives me x is equal to 7. Because on the left side, the 5's cancel. And on the right side, 12 minus 5 is 7. So then what I should do is I should check. Okay, I should check if my answer is correct by plugging back in. X plus 5 would be 7 plus 5. And I check if this equals 12. I get 12 equals 12, which is true. So because this is true, that is how I know that my work is correct. You should always check your steps though whenever you are not absolutely certain that you are correct. And at this point, no one should be certain because we just haven't gotten enough practice yet, okay? Certainty comes with experience. All right, number four, we have x minus 6 equals 18. Because we have x minus 6, I want to do the opposite of negative 6, which is positive 6. So I add 6 to both sides, and that gives me that x is equal to 24. If we plug that 24 back in, 24 minus 6 does in fact equal 18, and so we're all good there. Number 5, we have 3x equals 27. The inverse operation of multiplication is division, so because I have 3 multiplied by x, I'm going to divide both sides by 3 to undo that multiplication. When I divide both sides by 3, on the left the 3's cancel, so I just get x. And on the right side, 27 divided by 3 is 9, so I get x equals 9 as my solution. Number 6, the only thing different is now we have a negative sign. So negative 5x equals 35. We're going to divide both sides by that negative 5 because, again, the inverse of multiplying by negative 5 is dividing by negative 5. I do that on both sides. On the left, my negative 5's cancel. I get x is equal to 35 over negative 5 is negative 7 because a positive divided by a negative is a negative. Now, I want to make it very clear real quick that whenever I say cancel, so when I say negative 5x divided by negative 5, the negative 5's cancel, what I really mean is that they give us 1. And 1 is the multiplicative identity. So what that means is that when we say we want x alone, what we really mean is we want there to be 1x. Okay? We just don't write that 1 in front because 1x and x are the same thing. Okay? That 1 doesn't actually do anything to it. So when we say alone, we mean by itself, no friends. There's just one x there, no other x's. And so when I say negative 5 and negative 5 cancel, I mean that they divide to give us what they want or what we want, which is that positive 1 in front of the x. All right, number 7, we have x divided by 4 is equal to 12. We have x divided by 4, so what I'm going to do is multiply both sides by 4. And multiplying by 4 there, let me do that in red. Multiplying by 4 is going to cancel out that multiplication, or that division by 4 on the bottom, I should say. And if I do that on both sides, we keep our equation balanced. We end up with x on the left is equal to 48 on the right side. Number 8, we now have x over negative 3. So x is being divided by negative 3. I'm going to multiply by negative 3. because again, multiplication is the inverse of division. On the left side, these negative 3's divide out to just give me a 1x. And on the right side, 2 over 5 times negative 3. Remember, when we write a constant like negative 3, or an integer, I should say, that's really negative 3 over 1. We just don't tend to write the over 1 because in most cases, it's not unnecessary. But when you're multiplying by fractions, it's helpful to see that negative 1 is on bottom, because when you multiply two fractions, you multiply across the top and across the bottom. So the numerators multiplied together are 2 times negative 3 is negative 6. And on bottom, the denominators multiplied together, 5 times 1 gives us 5. And then we always check if that answer is fully reduced. So in this case, that is fully reduced. X does equal negative 6 over 5. But if it wasn't, then we would just have one more step to make sure we write it in simplest terms. So just remember to multiply fractions. So to multiply fractions, we go straight across. So 2 over 5 times negative 3 over 1 equals 2 times negative 3 over 5 times 1. And that's how we get the negative 6 over 5. All right, number 9. We have x plus 1/3 equals 5/3. So this is no different than question number 3 up there at the top, where we had x plus 5 equals 12. We are going to do the opposite of plus 1/3, which is minus 1/3 on both sides. But a lot of students tend to freak out here because we have fractions. On the left side, 1/3 and negative 1/3 add together to give us 0, so we just get x. And on the right side, now we have to add these fractions. Well, let's just go ahead and make a little note that to add fractions with common denominators mean that in the denominator we have the same value, both are 3's. It would help if I could spell denominator. Denominator. So to add fractions with common denominators, we keep the denominator the same and we add the numerators. So what we're going to do is we're going to leave that 3 on bottom, okay? But on top, we're going to do 5 minus 1, which is 4. So we do 5 minus 1 on top, but we leave the denominator the same. So 5/3 minus 1/3 is 4/3. I always like to think of pizza when I think of fractions. If you have 5/3 of a pizza and someone eats 1/3 of the pizza, well, now you have 4/3 of that pizza left because you didn't change how many slices the pizza was cut into. It might have been 3 slices the whole time, but you did change how much of it you have left. So we take away 1/3 from 5/3 and end up with 4/3. Okay, number 10, we have 2x equals 1/5. Just like earlier when we had 2x, we're going to divide both sides by 2. But this is another one that tends to throw students off. On the left side, these 2's cancel to just give us x. But on the right side, 1/5 divided by 2 tends to be confusing for students. So just remember that 1/5 over 2 like this is the same thing as 1/5 divided by 2. And when you divide a fraction by 2, we multiply by the reciprocal. So remember that division by 2 is really the same thing as 1/5 divided by 2 over 1. So if we multiply by the reciprocal, it's 1/5 multiplied by 1 over 2. So notice that 2 is now in the denominator, and so this is going to be equal to 1 over 10. So all in all, we get 1 over 10 as our result there. So the note there is that when you divide a fraction by an integer, that integer just multiplies by the denominator. But within that process, you can see that we multiplied by the reciprocal in the middle here. So to go from this step to the one after it, we multiply by the reciprocal. Where remember, reciprocal means to flip the fraction upside down. So instead of dividing by 2 over 1, I multiply by 1 over 2. All right, number 11, we have 2/3 x equals 4. We could divide both sides by that 2/3, But instead, it's easier to just multiply by the reciprocal right away. So instead of writing division on both sides by 2 over 3 like this, that's a little bit harder to work with. So instead, we're just going to go straight to multiplying by the reciprocal. If I want to cancel out 2/3 in front of the x, I multiply by 3 over 2. Because notice the 3 on top will cancel the 3 on bottom, and the 2 on top will cancel the 2 on bottom to just give me x on the left. But since I did it to the left, I have to also do it to the right. So I'm going to multiply by 3 over 2. Remember that 4 times 3 over 2 is really 4 over 1 times 3 over 2. So on top we multiply, 4 times 3 is 12, and on bottom 1 times 2 is 2. So then I need to simplify my answer. 12 over 2 is equal to 6. So just make sure whenever you have a fraction in front of the x, so when your coefficient is a fraction, we want to multiply by the reciprocal instead of dividing. Because if we divided, we would multiply by the reciprocal in the next step anyway, so we may as well just jump straight to that. We're going to do the same thing for number 12. Instead of dividing both sides by 4 over 5, we're going to multiply both sides by the reciprocal, which is 5 over 4. When I do that on the left side, the 5 on top cancels the 5 on bottom, the 4 on top cancels the 4 on bottom, so we just get x. And on the right side, 7 times 5 is 35, and 4 times 4 is 16. So we end up with 35 over 16, and that is the last problem in our topic. So I hope you enjoyed this introduction to solutions to equations. And please remember, because a couple of things from here are going to come up later, that if we get one solution like we did for all of these problems, these are all conditional equations. If we get a true statement, such as we would in identity, then there are infinitely many solutions. And if we get a contradiction, meaning a false statement, that would mean no solution. The only other note I have is make sure, like I did in number 3 up there, that you are checking your work all the time. Because if you do not check your work, you might make a silly mistake and then you lose points in the future for something that realistically you should have had points for. But more importantly than points is you have to understand that in real life, no one's generally checking your work when you like work on your house or you do your own finances. So you need to get in the habit of double checking the things you do. That way you're not getting yourself into bad situations where you make mistakes and you don't catch them. So it's a great habit to be checking your work all the time. That way you know that you're doing things correctly. All right, I hope you guys enjoyed this first one. See you in the next topic.